students, good afternoon. We have already gone through the property number 1, that is first shifting property, which is stated as Laplace transform of e raised to at into f of t is equals to f of s minus a. That property, here in that property we used to find for f of s, and then we were shifting the signal by s minus a. Where all s was there, we were shifting it by changing it by s minus a. Now we'll go with the next property, that is property number 2. So if Laplace transform of f of t is equals to f of s, then Laplace transform of t raised to n f of t is equals to minus 1 raised to n d raised to n by ds raised to n of f of s, where n is a positive integer. This property can also be said as a derivative of the transform property or multiplication property. Why it is said to be like that is, whenever a function is multiplied by t to the power of something, then such a property we are going to go with multiplication property, or can be said as derivative of the transform property, because here d by ds comes, so it is derivative. So whenever you are getting a function with multiplied with a t raised to something, then compulsory go with multiplication property, in which we need to find for first f of s, and we know that what is f of s, it is the Laplace transform of f of t. So you should have f of t. To get f of t, we have to see this function, leaving t to the power of everything is your f of t. Leave t to the power of and take f of t as whatever the remaining function. Take its Laplace, then you will get f of s. Here n is the power of t. Here n is the power of t. So if the power is 1, this will become minus 1 raised to 1. D raised to 1 by ds raised to 1 means it will become d by ds. It is the first derivative of f of s. Means we have to differentiate f of s with respect to s once. If n is 2, so minus 1 raised to 2 d square by ds square of f of s, means we have to take the double differentiation of f of s, and so on. So likewise we are going to apply for property number 2, which is known as derivative of the transform property or multiplication property. With the help of this, we will see the problems now. The first problem is, find the Laplace transform of t into cos at. Now if you observe, function is t into cos at. Into is there. We cannot take Laplace separately for t and separately for cos at. As already I have mentioned in my previous videos, if into comes or division comes, we should not apply separately the Laplace transform. If plus and minus sign is there, then only we can apply for separately the Laplace transform. But now here the function is the product of t and cos at. Here we are going to apply for the derivative property, or we can say it as a multiplication property, which is given by Laplace transform of t raised to n f of t is equals to minus 1 raised to n d raised to n by ds raised to n of f of s. If you compare this function with the given function, here n is 1, power of t is 1, so n is 1. Leaving t, everything is your f of t. So what is f of t? F of t is cos at. So hence, once we get f of t, we can find for f of s. So f of s is Laplace transform of f of t. Therefore, Laplace transform of cos at will be s upon a square plus a square, which is the standard result. Once we get f of s, we are going to apply L operator for the given function. Therefore, Laplace transform of t into cos at will become equals to minus 1 raised to 1, because n is 1, d raised to 1 by ds raised to 1 of f of s, means s upon a square plus a square. Minus 1 raised to 1 is minus d by ds of s upon a square plus a square. I need to differentiate this function with respect to s. Numerator is having s and denominator is also having s. So we are going to apply u by v rule for this function. Do not cancel this s and this s, because it is the addition of two functions in the denominator. So do not cancel this. So we need to apply u by v rule over here. So how it is stated, u by v rule, it is stated as v into differentiation of u minus u into differentiation of v divided by v square. Compulsory, you have to follow the procedure. V, what is your v? S square plus a square. What is your u? S. So differentiation of s minus s into differentiation of v, that is s square plus a square, upon v square means s square plus a square the whole square. This bracket will remain as it is. Derivative of s with respect to s is 1 minus s as it is. Derivative of s square is 2s. Derivative of a square with respect to s is 0. This is as good as differentiation of x square. X square differentiation with respect to x is 2x. Likewise, s square differentiation with respect to s is 2s. A square is acting as a constant with respect to s, so its derivative is 0. Divided by, you cannot write s raised to 4 plus a raised to 4. It is bracket the square, so keep it as it is. So once we write for simplify by writing for the derivatives, we will try to simplify the bracket by multiplying the terms. 1 into s square, 1 into a square. 2s plus 0 is 2s. 2s into s is 2s square. So hence you will get this as s square plus a square minus 2s square. S square minus 2s square is minus s square, and this a square will remain as it is. Denominator will remain as it is. Since there is a negative sign outside, multiply it inside, you will get minus a square plus s square. So I will write this as s square minus a square upon s square plus a square the whole square. So this is the Laplace transform of t into cos at. Thank you.